I'd like to talk about a resource that we plan on making available to the community, which is essentially a spreadsheet which can act as a clearinghouse for available instruments and technologies, not only for volatile measurement and recovery techniques, but generally for exploration. Especially of interest is instruments that can be used as part of missions for extremely small spacecraft, including CubeSats. Okay, here we go. So just to give a little bit more description, this started as an effort to translate science objectives into technology needs and engineering capability for the moon and planets, specifically in support of Project Constellation. And it's become a very important part of work that I've been involved with, along with Flexure Engineering and a number of other collaborators, which involves a working group which is exploring new paradigms for deep space access at much lower cost, but without in any way reducing science productivity or effectiveness. And we're looking carefully at the CubeSat paradigm, which has been so successful in basically creating instruments and allowing science-driven missions to be done now in Earth orbit after about 10 years of development. And the idea is to have an open access resource, an interactive spreadsheet, which people can add lines to on instrumentation at the level of disclosure that they're comfortable with. The only stipulation being that whatever entry goes in has to have a published online resource. That's to deal with any potential ITAR issues. And this is some of this work. The most recent work has gone on in support of 2 workshops sponsored by Flexure, which is the Lunar Cube workshop, which is now being held on an annual basis to look at CubeSats for deep space exploration for targets which include the moon being seen as kind of a gateway, just as St. Louis has been the gateway to the development of the American West. And also a workshop now held annually to look at cold temperature technology and science applications for the lunar surface as one of the most challenging environments in the solar system. If you can figure out how to survive on the lunar surface or even get to the moon with relatively few resources, you go a long way in opening up the rest of the solar system for exploration. To provide somewhat more details, let's see, am I going in the right direction here? So this is basically an effort to develop science to respond to science requirement development from the human and robotic exploration communities. And it started, as I said, at Project Constellation. And it's meant to be an extensive spreadsheet representing every aspect of each of the entries, which can include instruments or technologies, including their history, design, primary developers, applications, goals involved, nature of measurements, and requirements, and include a very wide range of instrumentation. It started really as beginning by the catalog from the Apollo J missions payload list and developed extensively from there. And we see it as potentially a central clearinghouse that would be available to everybody on an open source basis, and potentially allowing matching to be done between particular instrumentation needs, maybe for supplemental instrumentation, and providers of particular expertise or instrumentation, or people who could provide subsystems that would support instruments in very challenging extreme environments. In terms of what we're working on currently, well, we now have, or almost have a web-accessible version of LPACE, and it will be essentially on the lunarcubes.com website, which is sponsored by Flexure Engineering. And the idea is to allow people to enter the information at the fidelity that they're comfortable with, and that information will be entered, and then we'll essentially add it, we'll filter it and add it and put it online for people to take a look at as they wish to do so. And the idea is to have a very accessible and user-friendly environment to operate in. And we will reflect any sources, including, of course, NASA-funded activities, but any private companies, universities, or governments or other sponsored space programs we're happy to have any entries from all over the world. And we also essentially have a working group. We have an NLSI working group, actually, a survey working group now, I guess you'd call it, and we've generated it's generated a lot of interest from a lot of parts of the world. Just to mention some of the technologies that are of particular interest for people who want to, especially for people who want to get to the lunar surface, but thermal design issues, especially involving things like providing power and power storage at extremely cold temperatures. The electronics that will operate at extremely low temperatures, and there are electronics like that, and they also operate at extremely low voltage, so they're extremely efficient, have a very low noise, and operate at extremely high speeds. And they actually are available, but haven't been used thoroughly to populate entire systems at this point. Solar cell technology combined with battery technology, very important for power systems. And there are a number of instrument concepts, not all at low TRL, that support in situ measurement and monitoring capabilities that allow either reconnaissance to be done in advance of putting in more serious instrumentation to actually collect samples, or it can actually be done in lieu of actual sample collection, things that can provide things like identification of biological precursors that can provide for geochronology, things that 5 or 10 years ago people couldn't even imagine. Being able to provide providing handling for samples, any kind of manipulation, of course, always opens the issue of potential contamination, and of course, there's a lot more resources involved in actually collecting samples. So if it can be done using resources at the beginning to characterize an area, of course, that's much better than actually sending in things and then failing to get a really interesting sample. Now, the organization of the spreadsheet is that essentially we have pages for each of these different areas: logistics, surface sample collection and site survey, including field geology, subsurface characterization, surface environment characterization, things like exospheres, fields and particles of radiation on the surface, and separate sheets for geology, biology, and physics labs in situ, separate pages for observatories, and also a separate page for system-level technologies or component technologies that could be of particular interest in designing an overall mission concept or in the instruments themselves. And for each entry, which is essentially a line on each page, there's an extensive amount of information on point of contact, heritage, particular challenges in development, principles of operation, the kinds of measurements that can be provided, requirements for mass, power, and volume, as well as those are known, and any requirements for operation at the site or environmental restrictions, as well as this is also done for supporting technologies as well. Some of the developing compact instrumentation that's of particular interest for people in the volatile and surface assessment community include a whole range of instruments. Most of these developed over the last 5 years for organics detection, a number of concepts for compact mass spectrometer designs that allow characterization of a sample, even as a function of depth to a relatively, not particularly penetrating, but at least in potentially matters of millimeters. Interior structures and morphology, a number of instruments that can actually characterize surface down to kilometers. A lot of combined mass spectrometry and separation techniques, compact geochronology instruments, life detection, including concepts for very compact DNA sequencing instruments, and of course a lot of further work that's going on, including a paper that will follow this one, a subsequent paper on sampling, drilling, and subsampling techniques. That's just a smattering of entries that have been made relatively recently to the spreadsheet. And this is what the spreadsheet looks like. I'm not expecting you to read this, but we essentially have pages. This is kind of what the columns look like. We have pictures for the instrument if available. This is actually the page that's for the environment and surface volatiles. Example of a page for subsurface instrumentation. We essentially have categorized for generic instrumentation and then specific instruments that have information has been published about online that follow.
Pamela, you have 90 seconds.
Okay. And we also have a page that describes technology at the core level of technology and contacts to identify where people are. So we will very soon have a link from the lunarcubes.com page. And only thing we're working on now is making sure that we have identified for each of the entries a particular published online source of information. Thank you very much. Questions?
Great. Thanks very much, Pam. We appreciate your efforts to act as a centralized clearinghouse for all these pieces of hardware. It's really important because, as we all know, there's a ton of stuff out there. It's just that it's not collected in one place. So thanks for doing that. I also want to mention, by the way, you mentioned your focus group. Thanks very much for that. We are still NLSI. Just to make everyone clear on that, we will change to Survey when the new teams are announced, which we're anticipating is the beginning of October. But we are still the NASA Lunar Science Institute. So let's see. Are there? I don't see any questions for you. We'll give it just 15 to 30 seconds and see if there's anything. Otherwise, we'll just move on. I don't see anyone typing either. Oh, there we go. Russ Cox is. Or maybe not. All right. Okay. Oh, will there be focus groups this July? Russ Cox is asking. We are going to have actually a couple of announcements on the forum coming up. Right now, it looks like most likely not. The reason that we have focus groups at the Lunar Science Forum is because everyone's here physically, and without everyone here physically, the reason for that kind of diminishes. And what we want to do is utilize the time for the science talks. So what we're considering is setting time for that perhaps the next week or sometime soon after the forum as a suggestion. And of course, we will support any time that any focus group wants to meet.
Great.
All right. We have one more person typing. I'm going to give them about 10 more seconds and see if we get a question, and then if not, we'll just move on. All right.